Let him in.
All right, opening it up.
Hi, everyone. All right, we're just going to give it a minute to let everyone in from the waiting room.
Oh, there's quite the crew, eh?
Hi, everybody. Happy Monday.
Just looking to see here who's all coming in. We got a good group here. That's awesome.
Always a great group.
Absolutely.
All right, so we are going to get...
What is the word we were looking for? Remax rules? Is that what you said? Jennifer shaking her head, so.
All right, we're going to get started. Welcome to Mindset Monday, everyone. Please join us in welcoming once again Don Dell with Pillar to Post. And our topic today is going to be elements of an older home and what to look for. And I think Don has a pretty intense presentation for us today. And he has also promised to send us the slide deck following the meeting. So enjoy and take it away, Don.
Awesome. Well, thank you very much. So yeah, we're going to talk about older homes today. So we got a lot to go through. We're going to try and keep it moving. And we'll stop for questions at the end. If you have anything in the meantime, as we're going through, drop them in the chat as you're thinking about them. We'll review them there at the end. Okay. So let's get moving on older homes. Those of you who don't know, I'm Don from Pillar to Post. Here's our team. Myself, Susan, Brian, and Mike. So we're here to help anybody looking for home inspections and or home consultations. So that's who we are. So let's get into the meat and potatoes. What are we going to do today? We're going to learn some of the characteristics of these older homes. And what we want to do is help your clients know what to expect from an older home. And as always, why do we do this? Is to help you serve your clients better. That's the motto behind pretty much everything that we do for teaching. We're gonna look through what to expect, the older systems, some energy efficiency items, environmental items, and we're going to talk a little bit about a home with character. So a lot of older homes have older systems and components. You know, a lot of times houses are upgraded, but they're not always upgraded. So we do still find some of these older systems in place. And why aren't they upgraded? There wasn't a need to at this point. Buyers should not expect perfection. That's the biggest thing with an older home. And we want to talk about what is normal. So eventually everything wears out. Systems and components, but they're not all going to go at the same time. So we look at things like an old conventional furnace, 20 to 25 years, excuse me. Galvanized steel plumbing, somewhere around 50-year lifespan. Asphalt roofs, 15 to 20 years for typical. We do have better options. So these are just what was normally put in. You know, houses that have been cared for will settle into what we call a normal maintenance pattern, which means, you know, every 15 years you're putting a roof on, or every 30, depending how you're doing it. But not everything should be coming up at the same time. And that's important to be able to explain. You know, you don't have to do everything at once, but pick, you know, here we're going to do roofs, and then we're going to do windows, then we might do the plumbing, and we'll do them at different times. What is normal maintenance? So when we look at how much we should be spending on our annual maintenance, it really isn't an exact science, because every house is different, right? But a common rule of thumb is 1% of the cost of the home, and that will depend on where you are and obviously how much the house is worth, or about $1 per square foot size of the home. That's a yearly sort of figure that should be budgeted for. So a 2,500 square foot house, about $2,500 a year on average. Some years you might not spend anything, other years you might spend $5,000. So it really depends. The later method of $1 per square foot is usually what we like to use, because there are so many variations in pricing. So, you know, we're talking about buying a house in let's say Sudbury. It's going to be a lot different than buying a house downtown Toronto. Deferred maintenance. So imagine a home needing a roof. a new furnace and the electrical system is completely obsolete. That becomes expensive. So if we want to keep our houses moving forward so that we're not spending large amounts of money all at once, we want to get into that maintenance item. But we let everything go all at once, and it becomes very expensive to fix, especially with some of these older homes. We refer to that as deferred maintenance. So if the house hasn't been regularly maintained, that dollar per square foot is not going to work, because the first few years you're going to be playing catch up on what needs to be done in the house. I'll give a prime example. I was in a house a couple of weeks ago. It needed a lot of work, but nothing had been done in that house in probably the last 60 to 70 years. So it had lead water main, it had galvanized plumbing, it had a roof that needed to be done. There was so much in that house that needed. The furnace was an older furnace. It was probably close to 40 to 50 years old. So you look at that, that's going to be a lot more than 1% or $1 per square foot. So playing catch up is not where we want to be. So no home is perfect, but a well-maintained home should cost us about $1 per square foot. Some of the older homes have a lot of obsolete systems. So we're going to look at these obsolete systems: heating systems, electrical, plumbing. These are the systems that are usually the ones that have the biggest surprise for a home buyer, because it's not something that we normally would be looking for. And when we're looking at a house, when clients are looking for houses, they're looking at how much it costs, what the square footage is, what the neighborhoods are like, is it got good schools around, and these are the things that we can bring to them. Worn out and obsolete plumbing is a big one right now for a lot of the older houses that I've seen lately. So let's talk about obsolete electrical systems. So the concerns with obsolete electrical systems is, it may be inadequate today. So the knob and tube system was not designed for today's use. We're pulling so much more amperage and power through these wires. They just weren't designed to do it. So it could be unsafe. And oftentimes with some of this older wiring, it's really difficult to get insurance on the home. Not all electrical systems that are older are dangerous. And that's one thing. If you get an electrician in to look at a knob and tube system, it might be perfectly fine. But insurance companies are looking at it now saying, you know what, most of this stuff is past its life expectancy, so we're not going to insure it. So they're recommending, or actually demanding, that they're upgraded before they insure. There are a few insurance companies around that still will insure an older knob and tube building. You do pay a premium on that. So let's look here. This is an example of knob and tube. So you can see here, these are the knobs separating the wires. Open wire system. It's an open air system. It's when it was first designed, it was very good. One of the things that's missing is there's no grounding on this. So it's an ungrounded system. That's the first thing. Number two is they stopped installing this somewhere in the late 30s, early 40s. So it's old. It's done its time. With everything that gets older, it needs to be replaced eventually. And we can see some of the more modern wiring in the back here along the wall. So some of this has been upgraded. So using two different types of wires sometimes can be an issue. The knob and tube system was very good, but remember, it was air cooled. And that is very important, because when we start re-insulating homes now, we're insulating around these wires, which causes them to heat up. And that's where the concern comes in. So if the house was left as it was in the 1920s, the knob and tube wiring probably would be pretty safe to run. But now we've blown insulation into walls and attics and all that, so it can overheat. So this is showing a little bit of knob and tube here. It's showing some mixing of different wires, and they're actually tied together. It's hard to see here, but there's actually open splices. This is the problem with most of the knob and tube that we find, is that yeah, we only had 4 plugs in the house on that one circuit, but we want to put another plug here and another plug there, so we've added onto it and we splice in, and it's done incorrectly. And that can cause overheating in those points, but it also can overload the wires themselves. They are protected by breakers and fuses, which should keep them from burning up, but it still can happen with bad connections. Sorry, I just got to move. So when we looked at the previous 2 photos, we saw some knob and tube there. Usually it's a surprise to a buyer if we find knob and tube, but we'll find it usually on the second floor of the home, because it's the hardest spot for the wires to be changed. So a lot of electricians, well-meaning, want to do. The client says, well, I only have $8,000 rather than 10,000. Oh, we'll just not do the attic. We'll not do this part. Nobody's going to know anyway. That's starting to fade, fortunately. But there's a lot of the older upgrades that haven't been totally done. So we'll find a lot of knob and tube just for the second floor lights. They're very easy to find if we take the cover boxes off and we know where to look. And that's the key, knowing where to look. So let's talk a little bit about knob and tube, what it is. It was used from the 1880s to the 1940s, and it is an open air system. So it needs air around it to keep it cool. It's old and it is past its useful life. So here's an example of some knob and tube connected to a switch. Very easy to see when we take a switch plate off. You can see into here. There's a few other issues here. There's no electrical box. There's a few other items going on here. But the real telltale is this outer core here with a wire run in the middle of it, and that's there to protect it. So it is copper wiring, and it, like I said, it was a good system. It's just at the end of its life. So we wouldn't have seen this unless we took the cover plate off. That's the big thing. So this could have been totally concealed. As we look here, this is an older electrical system as well. It was really good when it was put in, but this particular one, you won't see what I'm going to tell you, but I'm going to explain to you. This is a 60 amp system, and that's what we find a lot of times too. So 60 amps is not enough for modern use. So with an older service, we most times will have to upgrade them to be 100 amps in order to meet our requirements for today. A lot of insurance companies don't want a 60 amp service. The other thing that's in older houses is aluminum wiring. And we're gonna we went older houses, not really old houses. This isn't all century homes, but it's houses that, 40 years and older. So 1960s to 1980s when aluminum wire was used. We started using that because copper was so expensive and aluminum made sense. It's still used today. And so a lot of times we'll see, hey, open the panel. Oh, there's an aluminum feeder in there. That's okay. Service feeds are fine, or multi-strand for the stove circuit, or a multi-stranded dryer circuit. Having those in aluminum is still fine. It's not the same as having aluminum wiring in the home. They're actually two different standards. Aluminum wiring is perfectly safe. The wire itself, there's nothing wrong with it. But the problem comes into when it is actually connected to the plugs, and if they're not compatible, or if they're not tightened properly, not maintained, they do become a little bit loose at the connections, and you can get some arcing there. So how do we identify if we have aluminum? It's going to be labeled aluminum or alcan. The color of the wire is not an indicator of whether or not it's aluminum. A lot of times we'll see, I'll get calls, hey, look at this, we have this aluminum colored sheathing, we must have aluminum wiring. Well, no, not necessarily. It might be, but it might not be. Most of the aluminum wiring we find has a blue covering. It doesn't have the silver colored covering. So really, it's a very not a great way to identify aluminum. You have to look in the panel, and that's the right way to determine whether or not we have aluminum. If it says aluminum or alcan on the sheathing, obviously we're going to know, but most of the time it doesn't. So opening the panel is the right way to tell. And the other thing about aluminum is that it's actually bigger. So the wire sizes are bigger. And if you look at the photo here, you can see that one is a number 12 and one's a number 14. They're both rated for 15 amps. So the wire size had to be a little bigger because it's not as conductive as copper. And an interesting thing to note, because it's not as conductive, but most of the power that comes through a wire goes around the outside of the core. And it's just an interesting tidbit. So the size of the wire is because we need more surface area for the electrons to run on. So we also have ungrounded wiring in houses, and that was done from the 1880s to the 1950s. And I think when we talked about knob and tube, we mentioned that there was ungrounded. And that went on right through to the 50s. We changed to different types of wires, but it still was ungrounded. So basically, it just doesn't have that bare ground wire. So if we look at plugs in a house, we can see here the top plug on the corner, that's an ungrounded plug, and that's correct. That's what we want to see. So on the bottom, you see ungrounded and grounded. The problem we have with this type of wire is that people put in 3-prong plugs with ungrounded. So it makes it look like it has a ground, but it really doesn't. So that doesn't give us any protection from shock or static buildups. It's a hazard with some of the new modern electronics. And it can be actually a shock hazard as well, because the grounding, there's no ground for the power to go to. Bootleg grounds, and this is something that's done because your neutral and your ground are actually tied together in your main panel. Some homeowners will fake it by putting in neutral to ground jumpers. Very unsafe to do that because it's not designed that way, and it can really cause some fire issues, and it can actually damage equipment that's plugged into it. So it needs to be done right. Bootleg grounds are very hard to see and very hard to tell unless we actually open the plugs and look for it. So ungrounded wiring, again, it just doesn't have the ground. Was done up until the 1950s. And you know, the one way to fix ungrounded wiring to make it safer, and this is a fix that is actually recommended by ESA, is to protect the circuit with a ground fault circuit interrupter. And that can be a breaker, or it can be a plug at the beginning of the system that pigtails, and not pigtails, excuse me, that is wired correctly so that all the plugs after it are, protected. So that's one thing to do. But what needs to be done is it needs to have, see how this says grounded receptacle? There's little stickers that would go on that say ungrounded equipment. So no equipment ground. And that's important when that's done. So we got quite a couple things with wiring. We'll just do a small recap on wiring. Knob and tube wiring is old and worn out, probably needs to be replaced. Aluminum wiring from the 60s to 70s. It's still a good product. It just needs a few extra steps. Most of the time, if we have the aluminum wiring, it's going to require an ESA inspection for getting your insurance. One thing to note with ESA inspections now is any ESA inspection will require upgrading of any safety components. So if there's GFIs missing, if the circuit sizes have changed, like a 40 amp for the dryer in the 80s was allowed, they'll make you fix all that up. So that's one thing that's being done now. And it's being done just to protect the homeowners. And then we have to move into older heating systems. This is one we don't see a lot of. I don't personally. I find a few every month, but it's not as common as some of the other items. But a lot of times we'll end up with old heating systems. You know what, they work. I had an oil furnace last year from the 40s, and the thing ran like a champ. She ended up changing it this year, only because she wanted to sell the house. It still worked fine. There was nothing wrong with it, but it was not efficient. So older cast iron boilers are still very common. The older octopus furnaces, we see a few of them, and they were basically no blowers in them. So they used physics, heat rising, and cold air dropping. That's how the old octopus furnaces would work. So they didn't have a big blower in them. But the boilers are still around because these cast iron boilers, really, they last forever. So here's a picture of an older boiler. It's probably from the 20s or 30s. And it's still chugging along. It does its thing. The one bad part about that is there's probably asbestos around that. And we're going to talk a little bit about asbestos as we go through. So this is the boiler. This would be, with these boilers, the lifespan is really, they last forever until they crack. We've seen some that are 70, 80 years old, and they still work. So that's a testament to how we used to build things. Here's an octopus furnace, and you can see that this obviously is an older photo because I don't have any new ones. We don't see them very often. I've seen 2 in 12 years. Again, the basic premise, this is an oil-fired one as well. But the premise is the hot air rises out the top and the cold air falls in the bottom and just creates its own circulation. Just keeps going round and round as it heats up. They worked very well, but they were limited because of the fact you couldn't force the air through them. The other thing too with the older furnaces, they usually ran up through the center of the house. And now when we pipe in our new furnaces for our ducts, we're putting them under windows and doors. And there's a reason for that, is that's where the cold air is coming in. So we want to warm it up as it's coming in, makes it a little more efficient. So those are the really old ones you're going to see. There are still some conventional furnaces in operation. Conventional furnaces, basically no blowers in them. There's a blower on the bottom, but it doesn't have an induction motor. And then we get mid efficiency, and then we have the high efficiency. Today, when we're replacing them, the only thing we can use in Ontario is a high efficiency furnace. You cannot get a mid efficiency, and you cannot get anything lower than that. And that's just our new environmental to help save gas. Excuse me, sorry. Obsolete plumbing, galvanized steel pipes, and lead water mains. Those are the two big ones. There's all kinds of weird plumbing you can get. We're going to talk about water coming in rather than the effluent going out of your house. When we look at the stuff going out, we have the cast iron, which can crack and it's getting older. And then we have one called Orangeburg. It's an old pipe that was asbestos. And there is some around. I actually found some in Guelph not too long ago. But for the water pipes, the main things we're looking at are the galvanized steel and the lead water main. So with galvanized steel piping, they were used for the water mains and interior of the houses from about 1920 to 1950. The problem with it is it corrodes from the inside out. So when you start out with a pipe that is 1/2 inch, and then after 40 years, you've got, a 1/4 inch of water flow coming through, the best way to know if your galvanized piping is still in good shape is to monitor the flow of water in the house. As the flow starts to decrease, then you're going to know that maybe we have some corrosion going on and it's time to replace that piping. It has a functional life cycle of 50 years and it hasn't been used since the 50s. So that tells us something right there. Galvanized plumbing that's in the house is past the end of its life cycle. The exception to that are barns and farms and that kind of stuff. There's still galvanized piping used in those locations, and that's a whole other presentation. So sometimes you won't find the whole house being galvanized, but sometimes it's to the second floor. Sometimes it's only to one toilet. It's an insurance issue. The insurance company really doesn't want galvanized in because it is at the end of its life and it's prone to leaking pretty much any time. So as we look at the next photo here, you can see there's some galvanized plumbing here. Sorry, you can't see me pointing at my screen, but I'm going to show you with my pointer here. So this is newer galvanized put in, and there's some of the older sections. I mean, this is just at the point where, regardless of what it is, you really should be replaced. And replacing plumbing nowadays, especially in some of these older houses that only have one bathroom, it's not that big of a deal. We're running PEX pipe right behind it. Like it's a pretty easy thing to do. On a look here, sometimes that's what we're seeing. We'll see the galvanized and the copper. If you don't look closely enough and peel some of that stuff back, you can wrongly assume that it's copper pipe. So it's important to look in strategic locations in order to find this. Let's look at a water main coming in. This is why we don't want it. This is actually a photo that I took. That is right at the end of its life. That's a galvanized water main. That comes right into the house. And that is at the end. That is going to leak at, some point not too far in the future. Sorry, we'll go back here for 1 second. If you were running an insurance company, would you want that in a house you were insuring? That is a costly item to have when it breaks because it can cause a lot of damage if there's any finishings in the basement. In Cambridge, there's a couple of areas here that have a lot of lead water mains. There's a lot in Toronto. Guelph has areas, old parts of Kitchener and Waterloo. There still are some lead water mains in service. Sometimes the water mains themselves out in the road have been replaced, but a lot of the houses still have lead from the road in. Usually this pipe is pre-1930s. So it hasn't been used since 1930, and we're going to talk about that. But how do we identify it? Like if you're looking at this, well, let's have a little look here. This is the telltale sign of lead. It's got a bulb, and that's where the lead was melted into it to join the two pipes together. So they basically expanded the lead and they filled it with lead in order to create a joint. So it's very, very easy to see. We can also scrape it. Just a little scraping with your knife, it'll come up shiny. Whereas galvanized, when we scrape it, will just be a dull gray. This will come up shiny when you scrape it. Lead is very shiny. The other thing that some people will do is they'll test it with a magnet. I like to use a little scraping just to make sure, but a magnet will work too. Lead and galvanized are non-magnetic. So a little magnet touching it, it doesn't adhere. We can be, pretty sure to say it's not a steel pipe, all right? But then again, copper is not magnetic either, so that's why I like to scrape it. So what's the implication of having lead in your home? It's a health concern. If you've been away on vacation, water should be run through your lines to flush them out. It's the water that sits that the lead will leach into it. If it's constantly moving, there's very little health hazard to it. Most testing for lead will indicate there's really nothing going on. There's no lead in the home. But it still is something that should be replaced. I know a few houses that I've done had lead. The guys, some of the clients have put in reverse osmosis systems, that kind of stuff, before they get ready to change it. But ultimately, it should be changed. It's at the end of its life, and it's just one of those old products. Now, an interesting thing about lead is it does oxidize. So in the pipes, it probably is not leaching very much because it's got a coating in there, an oxidative coating. It's not allowing the lead to leach in. The warmer the water, the more leaching you're going to get. The colder the water, the less leaching you're going to get. The longer the time it's in contact with it, the more you're going to get. The other thing is pH levels. Around here we have very hard water, which is a higher pH. So the lead is less of a concern in the area I'm in right now. But as you get into like the Toronto area, the water's a little more acidic. It really depends on the area you're in. And you have to look at what the water quality is as well. The reality is most people are going to want to replace it anyway. And a lot of the cities are providing grants in order to do this as well. I know, for example, Brantford, if you have lead water mains, there's some good grants or tax rebates for replacing your lead water mains. So most old homes are going to have some old systems. It doesn't necessarily mean they have to be replaced, but it's something we need to know in order to budget. But things that are acceptable to me may not be acceptable to you. So a lot of times it becomes a personal preference. We'll go through houses and we'll look at an older furnace and people say, well, it's an old furnace, it's only 80% efficient. That's one thing I want to replace right away. And that's perfectly fine. But that old furnace may last another 10 years. So replacement is not always necessary until it's at the end of its life. But being aware of what these older things in the house are, it really helps you to help make your client a little more educated, and they can really evaluate that house on a bigger scale. The other good thing is you can budget. Budgeting is always a good thing because, as I've recently been made aware, money does not grow on trees. So I had to teach that to my children. They think money grows right on the trees, and it doesn't. I checked. All right, so energy efficiency. That's a big thing in older homes. As we've taken our houses from old single pane glass to dual pane, triple pane sometimes. Insulation levels, when some of these houses were built in the 20s and 30s, have an inch or 2 inches of insulation, sometimes none. And today we're putting 18 inches of insulation in an attic. We're using 2x6 walls full of insulation. We're trying to get our R value, which is your thermal resistance values, in walls up to a 32 and up to 60 in an attic. Some of these old houses, you're lucky if you got an R5. So that's a big thing in terms of how to maintain your costs in a home, how to reduce your overall operating efficiency of a house. Let's look at that. So older windows, insulation. So like I said, most houses don't have adequate insulation. It's really not economical to upgrade a lot of times. unless the attic's accessible and you have a basement or crawl space accessible. It can be done. And new spray foams, and we won't akin them to the same thing that happened with Eufy in the 70s. The newer spray foams are safe, but they can get in between wall cavities and do that. And a lot of times what we would say to clients is, you know what, yeah, you know, you're going to be redoing that bathroom. So when you do that bathroom, why don't you take the wall off, re-insulate, now you're going to have a warm bathroom. You keep doing that as you remedy different areas of the house, rather than trying to tackle the whole house and try to make it energy efficient. It's not going to happen. But there's steps you can take along the way to improve the energy efficiency of your home. So older windows. Single pane windows are just not efficient. They don't fit tight. We get air coming in them. A lot of times though, with these older houses, people will upgrade the front windows because they look nice, but they won't worry about the rest of the house. And that's perfectly fine as well. Everybody has their own way of doing it, but to get us up to make the home a little more efficient, you know, we do need to upgrade the windows. Windows are probably the single most expensive thing to do in a house, other than building it, but as a component. You know, a roof on a 2,500 square foot house is probably going to run you $7,000-8,000, 7 to 8, not 78, excuse me. You know, a furnace is and air conditioning run you 10. Doing new windows is going to be 15 and up. So there's a significant amount of money that has to be spent on that, but they don't all have to be done at the same time. Just an example of an older single pane window. I'm sure everybody's seen one or two of these. This one's just a sideways slider. I mean, air comes in around these. A lot of times we'll find them in the winter when we're doing inspections. People have them shrink wrapped, and that's just to keep the air from moving in and out of them. Here's another. This one is actually a little more efficient, and this one is actually not too bad because we have the aluminum storm window on the outside, but they're still nowhere near what we have today. And you can actually see here that they've used a putty around them to try and stop the drafts around them. So that kind of gives you an idea of how much air was coming into there. You know, sealing this window up in the winter because you're not going to open it with a removable caulking, not a bad idea. But budgeting for upgrade is going to give you a better functioning window. It's going to be less maintenance every year. And quite honestly, they do look a little nicer. You know, so the appearance of the house can be upgraded as well. Best energy savers. So heat loss in a home it can happen two ways. We're going to get hot air drafting through the open windows, doors, etc., and coming in that way. But heat, that's your convection. That's actual movement of air. Now, conduction is the transfer of heat through a product. So heat and cold can still travel through the walls and on a cold day and make cold walls on the outside. I wish I had a photo of this, but if we take a thermal image of an exterior wall in a house during the winter, we will see that the studs in the wall are actually cooler. And that's because of the conduction of the cold through them. Vice versa, in the summer, we'll find that the studs will be actually warmer than the walls. So we put the insulation in our walls, and it's designed to slow down the conduction, but it doesn't eliminate it because the insulation the conduction will go straight through the studs, where the insulation will stop it in between. So there still is, it's not 100%, but it's a lot better with a well-insulated and well-vapor barriered wall. So what can we do? The best way is your convection. To get rid of that convected heat loss, that's the first thing and the easiest thing to do. So weather stripping your doors, windows, caulking around them. You know, we talked about the plastic over the windows. Glass doors on your fireplace, that's one that most people don't think about. We had a wood burning fireplace. There's a lot of cold air that can come down there and a lot of warm air that can be released up through. So just a set of glass doors on there can actually make a big difference. And you know what? Increase the level of insulation in the attic. That's an easy thing to do if the attic's accessible. That, you know, it's about, I think it's $1 a square foot or less to insulate an attic. So small investment, but huge paybacks. The other thing you can do is get a heat loss consultation or an energy audit. Older homes aren't as energy efficient as new ones. We know that. But we can look at areas through a heat loss consultation or an energy audit to see exactly where we're losing our air from. They will tell you which windows They will tell you how much insulation's in the wall. So this is a good thing for people to do. When we're doing new furnaces and air conditioners and things like that, there are a lot of credits out there that can be used from the government, and they require, quite honestly, to have a heat loss consultation done. And you can actually get money back. When we did our house, we had already upgraded our insulation, but if we hadn't, we would have been paying about 25 cents a square foot to insulate a top up our attic, which is a good deal. So those are things that, you know, you can bring to your clients, say, hey, look out, there's always something going on. Might not be something right now, but maybe next year, if they're frugal, or if they, you know, are having, you know, think it might be a little out of their range, but do things like that, like get the energy audits done. You know, utilize the money that's out there, and that can really help to get these upgrades done sooner. I mean, a lot of times they're free too, especially when you're doing upgrades. So a recap of so older homes are not as energy efficient. I don't think we don't need to put that in sky rating. We all know that. But there are a lot of things we can do to save energy without spending a ton of money. Insulation upgrades, you know, may only be practical during big upgrades, but it can be done. But attic insulation is a very good way to save some money. So some of the next part is talking about some of the environmental issues. And most of you will have seen these as well. So we're going to look into oil tanks, asbestos, and lead. So oil tanks are an environmental issue because oil spills are expensive to fix. Some of these tanks are underground. They're really hard to find sometimes. Especially if the basement's all finished and there's no indications in the line, there could be a buried oil tank. We would never know. But there are signs for most houses. You know, oil tanks for insurance as well. With an oil tank that's more than 10 years old, most insurance companies on a new sale or a new transfer will not insure a 10-plus-year-old oil tank. They're just prone to leaking. Leaking fuel oil into a house is very, very expensive to repair if it can be remediated. Sometimes you know, if it's a full load of oil into a basement, you can that could be a write-off of that house. That's how extensive it can go. Once it soaks into that concrete and the walls and everything, you cannot get rid of that smell out of the house. So if you have an existing policy and you own the home, sometimes up to 12 years, they'll be asking for replacement. There's always exceptions to these. These are not hard set fast rules. These are the averages that we've seen over the years. The new thing with oil tanks is a lot of insurance companies are requiring them to be outside. They don't want them in the house anymore. So little things to consider. There's a lot of environmental issues with these tanks, but there's new technologies coming out too. Some of the newer tanks are double lined. They're using plastic, which is not really plastic because they're cross-linked polyethylene for the tanks, and they have a steel cage around them. We're doing double walled tanks. So they're a little more expensive, but a little easier on your pocketbook for insurance and less likely to leak and cause major issues if they're monitored frequently. Here's an old oil tank here. Nothing wrong. It's pretty typical installation. And that tank is a bit older. You can see a little bit of rust starting at the bottom, but not bad. So oil tanks are going to be one of those things. Just know that there's requirements for insurance. They will need to know the age of the tank, which is marked on every single tank, has a label. If it doesn't have a label, it's too old and it'll likely need to be replaced. And they also will note the thickness of the tank. And 2 millimeters is generally what you would want to have, or thicker, in order to meet your insurance requirements. So the other thing we have in older houses on the environmental side is asbestos. If asbestos is in bad shape, it probably needs to be, remediated. And we see it's in a friable state. So that's where if you look at a tile or a piece of asbestos, it's pretty sturdy and rigid, but once it becomes dusty, that's when it gets into the air, and that's when it creates the issues for people, which is the mesothelioma, or can cause lung cancer. But it's not from one exposure. So if I took a handful of asbestos dust and threw it up in a room, with 30 people in there, we all got a little breath of it, likely nothing's ever going to happen. But it's that long-term exposure, continually being exposed to it, causes the issue. Every time an asbestos fiber gets into your lung tissue, it actually sticks because of the structure of it. It's a fish-hook structure, and it sticks into your lung, and it creates a scar. And so, 20 scars isn't bad out of the, however million oxygen transfer alveoli we have in our lungs. But as we keep scarring them over, we can't breathe. And that's the real problem with asbestos, is a long-term. Well, encapsulation is a good way to take care of asbestos, which encapsulation just covering it. So it could be tiles on the floor. We can put another floor surface over them if they're in good shape. That is actually fine to do. But a lot of homeowners just don't want it in their house. And that's the problem that we have to skate with older houses, is being able to explain, hey, there is asbestos in here. But by the time you're done explaining to them that, hey, it's not that big of a deal, it can be dealt with, and here's the things you should do, 99% of the clients I've dealt with are like, yeah, no problem, we know how to deal with this now. It was a fear they have, and that's with anything in life. If we don't know about it, it can be scary. So my job as an inspector is to be able to explain these things in ways that make sense to the client, be able to relate them to them. And your job as an agent, and I'm not telling you what your job is, but my interpretation here is to help educate your clients as well. So we're really doing the same thing when it comes to these types of issues. So asbestos, like I said, it's going to be in the older houses. It's still being used. Any house pre-2000 has the potential to have asbestos in it. So it's not just the old houses, but even 20 years ago, we were still using asbestos in some of the products in the house. Some of the heat shields and furnaces, some of the plasters and stuff that we use will have it in. So let's go and look a little bit more about where asbestos is found. Floor tiles and floor glue, so those 9x9 tiles on the floor, those are a really big place to find them. They're only a hazard if they're in poor condition. Really, we would just recommend covering them over as long as they're not in bad shape. The only way to tell if a tile or a product has asbestos, and this is really important for most products, it needs to go to a lab to be tested. There's no way to visually tell you that something 100% contains asbestos. We do know from experience that some products that we will see more than likely will have asbestos, like this one. That is definitely an asbestos product. But there's another product that looks very similar to this that is not. So testing is really where you want to be. This is actually just insulation over old steam pipes. And then we have the asbestos floor tiles. So the one in the top corner, we start seeing that. Yeah, that's at the point we're starting to deteriorate. Maybe it's not too bad at this point, but really want to make sure we're doing what's right. No other loose tiles. But it's actually the reason that I put this photo in here is the tile itself has asbestos in it, but it's the glue underneath that can actually contain more asbestos. And that's the part people don't know. So if we're taking the tiles out and people are scraping the glue, yeah, they've removed the tiles and the asbestos tiles are out, but they don't realize that the glue underneath has a lot of asbestos in it as well. So education is key here. But asbestos can be in a lot of different places. We use it around our heating systems. You can see here around the pipe. This is one that we'll see a lot around the vents. And this is just pulling one of the vent covers registers off the floor. This asbestos was wrapped around the vent boots in order to protect the wood framing from pyrolysis. And pyrolysis happens when we heat wood to 80 to 90 degrees Celsius and hold it there. It actually chemically changes the wood to charcoal. And we know how well charcoal lights. So this is something that was put in to keep the home safe. Unfortunately, this is a high wear area. So these fibers are actually a place that I would recommend replacement and or sealing of them. Sometimes they'll use a little flashing, they'll create a little boot around them, or somebody will paint them or caulk them depending on how bad it is. But this is something that when we see this is a professional needs to look at this. When we start seeing the deterioration of the coverings, that's when you want to recommend a pro come in and seal that up. Does it need to be removed? Not necessarily. But it does need to be sealed up so that there's no friable materials getting into the air. And asbestos removal, if it's over, I think 5 square feet, needs a professional remediation done. I think, sorry, it's 4 square feet. Small amounts you can do yourself using proper procedures and practices. We don't recommend it, obviously, because if you do it wrong, you could get into issues. But it should always be done by a professional. We also used to use it in these popcorn ceilings. And this is something that, I mean, if I had people put up their arm that have scraped the popcorn ceiling in their life, probably half of you would say I was in a room or around people that did that. Yeah, I see Lincoln's hand going up there. Yeah. And you know what? We just didn't know. We didn't know it had asbestos in it. I didn't know until 15 years ago. I've taken a few of these down myself. And that's the problem is education is what we're going to start doing. So when we go through an older house with somebody and we see this or we see this, we'll say, hey, you know what? When you're doing renovations, it might not be a bad idea to test this because it could contain asbestos. And the people go, whoa, asbestos. Yeah, but it's okay the way it is. And every old house pre-2000 is going to have this in it at some place. So as long as we keep it in good shape, it's not a health hazard. But to remove it, if you want to go flat ceilings or some of the modern things that we're doing, you should test it first to make sure. Not all popcorn ceilings have asbestos in them, but a large majority do. And then we look at these 12 by 12 tiles over here. These are ceiling tiles. A lot of those did contain asbestos as well. And again, you cannot tell by looking at them. I've heard people say, hey, well, this particular pattern of holes in it is usually asbestos. Well, that might be good, but that tile has been made for 70 years with the same pattern on it. I'm not going to trust that it does or doesn't. So the best thing to do on these is to sample it. An interesting thing about asbestos sampling that a lot of people don't know, one sample is not sufficient. Taking a single sample of that ceiling or that popcorn or the insulation in the attic is not acceptable. It has to be 3 separate samples taken, a minimum of 4 feet apart, and all 3 samples have to be separate and tested separately. And why is that? Well, number one, it's part of the Occupational Health and Safety Act, but the distribution of asbestos in products is not uniform. So especially when we look at something like the vermiculite here, this was used in walls and ceilings as draft stops around doors, etc. So that product was mined. Most of it came from Libby, Montana, and there were veins of asbestos containing product in there. Some of it isn't, some of it is. But who says that that bag you put at the front of the house that contained asbestos is the same as the bag we put at the back of the house? So we could have 12 bags and 4 of them have asbestos in them and 6 of them don't. I mean, it is really that random. So that's why the testing in the area is very important. But as per new rules for the Canadian Association of Home Property Inspectors, NACHI, InterNACHI, all the home inspection companies, as well as the Canadian government, the CMHC, if we see vermiculite, it is to be considered an asbestos-containing product. Now, if we find this in an attic, do we recommend removal? It's one of those things that it depends on the house again, but if anybody wants to do work in the house, so we all know that older houses that this product probably would have been put in, probably there's a good possibility they don't have overhead lights in the bedrooms. And what does everybody want in their bedrooms? They want the overhead lights. They want to put a fan in. They want all that. So electrician has to go in the attic, and that's where the problems come in. A lot of them don't know what they're looking at, but you can have refusal to work in your attic because of this product. So you can't do the things you want to do to your house. So there are things that need to be considered. Lead-based paints, very popular prior to 1968. The concern with lead-based paints is kids eating it, quite honestly. But it can also be a hazard to ourselves. On wear surfaces where you're constantly touching them, we can have transfer of lead. But the big thing is when we're repainting or redoing trim in an older house, we want to strip that old paint off. Well, we don't want to use heat, and we don't want to use a sander because we're going to put that lead into the air and we're going to end up breathing it, which is bad. So using alternate means of stripping, like chemical stripping and whatnot, is very important in this. The problem with the lead is it is a neurotoxin. So it really affects your brain. And there's a lot of things that can happen. They say, you know, they're used to say, you know, Alzheimer's, dementia, things like that can be lead related. There's a lot of things that can happen with lead if it gets into your system. You can treat lead poisoning. And that's one thing, you know, they can chelate lead out of your system. It takes a long time, but it can be taken care of if somebody does get lead poisoning. But it's taking care of knowing that older paints do have lead. So if we have lead paint, we want to test it because that's the only real way we're going to know. You can't really look at it and say, oh, that's lead paint. You know, if it's an old house, we're going to be pretty sure it is, but we still need to test. So what can you do for remediation? You can remove all the old trim and replace it with new stuff. I don't like that idea because I love old trim in houses. That's what makes it a gorgeous old houses. So, you know, we want to chemically strip these and take the proper precautions when we're dealing with lead. So environmental issues can crop up in new and old houses. If it's not mold and poor air quality, it can be lead-based paints and asbestos. You know, with environmental issues, they do require specialized testing, and not everybody can test for these, and some of them are beyond the scope of a standard home inspection. We do, our company here, the Don Dell team, we do some of this testing for asbestos and whatnot. It's really tough, though, to do an asbestos test on a popcorn ceiling in a house when somebody's buying it, because I'm pretty sure if I go and start scraping samples of that ceiling off, somebody's not going to be happy with me. So it's generally something we would recommend doing after they've bought the house. We can come in and help them with that. And we want to talk a little bit about older foundations. And this one's a little quicker here. We're moving through pretty good. Older foundations were not designed to have a finished basement. They're, you know, expect moisture and dampness. And if you're going to finish it, they're going to take additional steps. It's just not, it's not if, it's when a stone foundation will have moisture. The best defense against moisture in older basements is the groundwater control. I'm sure we've all seen an older foundation. And that's the biggest thing. We do have other types of foundations, but this is the one for the older homes. It's the one that needs a lot of work. They're good foundations. They're thick. They support the house well, but they are susceptible to water infiltration. So quickly through a home with character. Homes with characters have bulging plaster, worn hardwood floors. We get sagging floors, right? So we want to look at plaster. So this is just plaster, lath. That's a lath. Lath and plaster. That's exactly what it is. So that's an older product, right? And this could contain some asbestos as well. But it does end up, you can end up with plaster separating, and that's where you get the bulging. So after plaster, we had gypsum lath, which were basically 1 foot by 8 foot boards that were put up, and then we put two, like gyprock. It was actually, the first name of it was called gyprock. You'll see on ceilings when it's in, you'll see a little bit of bowing on the ceiling sometimes from the weight and whatnot. Most commonly used up till 1960, and then we went to drywall. And the nice thing about drywall, we get sharper corners, less curving on it, but a very easy way to tell if you have, I usually use the back butt of my flashlight. I just tap the wall lightly. If I get like a really high pitched tap, then I know we probably have plaster, and a really thunk will be drywall, because it's just, it doesn't have that hardness to it. It's a lot softer product. So worn hardwood floors generally are cosmetic issues. I mean, some people really like the look of a worn floor. I personally do. I like the small floors. I like to see the imperfections in it. I like to see, you know, the last 40 families that have worn holes into it. It's just, to me, it gives character. But, you know, they can be refinished, but they can only be refinished if we have enough material left. And generally, these older floors get 1 refinish. Sometimes 2, depending on how badly worn they were the first time. So just a thing we look at. If you want them to look new, you're gonna have to replace them, unfortunately. So this one has been sanded. That's pretty easy to tell. The nails have been sanded. They put extra nails in. So this is a good indication of the fact that there's probably not a lot left there for us to refinish. This is how some of these old hardwood, this is actually a softwood floor, but it's the same, you get your plank subfloor, and then they put the tongue and groove on top. So this kind of just a neat way to see what it looks like. I apologize for the fingernail in there. That's kind of gross. I didn't notice that until now. So, it is a cosmetic issue. If there's enough wood left, we can refinish it. If you do have to tear it out and replace it, it can be quite expensive. You're $5-6 a square foot. With older homes too, one of the things that a lot of people ask about is floor squeaks. Most of them are going to squeak. That's just what it is. Your stairs are going to squeak, your floors are going to squeak. And a lot of times people are moving from newer houses into an old house, and they don't really understand that those are normal noises. I always joke around, it's, with the husband or the wife, guess you can't sneak in now, because you can hear every step coming across that main floor. Yeah, have some fun with it. But I mean, the real thing is really not an issue. It's more dependent on what the buyer wants. Sometimes you can get at the subfloor and re-nail it or screw it. Sometimes a little bit of talc on the floor, if they haven't been refinished too many times, you can actually spread talc on the floor, get it in between the boards and cracks, and it'll actually lubricate the two boards so they don't squeak. It doesn't always work, but there's some things that can be done. But if it's really at a point where it's not something they can live with, I mean, it's going to be a replacement. And sagging floors. So how many people have had a sagging floor in a house? I'm sure most of you have seen this. It is due to settling. I mean, most old houses will have a little bit of a sagging floor. They'll creep a little bit. But when we start seeing, and I've had a few where, from one side of the living room to the other, you got a 6-inch drop, that's not normal. But having a floor that's wavy, maybe there's a bump where the beam is because the outside walls have settled a little differently than the center beams in the house. We get asked a lot of times, well, is this a structural issue? Are we going to is the house going to fall over? Not necessarily. And 90% of the time, it's probably not. But being able to look at it and explain it's important. Most houses, and I would say with a sagging floor is, we get people saying, well, is this an issue? It's only an issue if you don't like it. But it's perfectly normal for the house. And in my opinion, that's the character of an older house. That is really I find that has such great character. You're in an old house when you have floors that aren't perfectly level. And the other thing with sagging floors, we'll get asked a lot, can we straighten these out? Yes, you can. You can straighten out sagging floors if you have enough time and money. It's not going to be cheap. Sometimes it involves actually going right down to the floor joists and putting new floor joists on in order to get them straight. So, looking at it, is it worth doing or is it worth living with that? Is it that bad? If it's a 6-foot drop across the floor, I'd say there's some issues. But, the normal little wagging in the floors is probably not going to be a deal breaker. So recapping that, older homes are going to get worn out. I mean, we've had, house from the 1800s, probably has had 20 or 30 families living in it. Maybe not that many, but, cosmetic doesn't necessarily mean it's not going to cost a lot of money. If it's floors and things like that, or repairing plaster that starts to bubble, that can be a bit costly. Every buyer's different, as we well know. If everybody was the same, man, our life would be easy, wouldn't it? Because everybody wants the same thing. But that's not the world we live in. So, we have to work together as agents and inspectors and for that matter, appraisers, and set the expectations properly. Just because a floor slope doesn't mean it's a bad thing. Just because you have asbestos in there doesn't mean the house is dangerous. Just because, there's so many things we can say, but it's really looking at the entire picture and looking at exactly what's happening rather than picking on an entire house and saying, these are the 7 issues and they all have to be done now. No, they don't. This is the one thing that needs to be done. These things can wait. And it's, setting that expectation up front that there are going to be things to fix in an older home, I think really prepares the home buyer for the inspection process, which I appreciate if you prepare them. But, it makes the deal go a lot smoother when we say, hey, it's an old house. These are the things that we may find. They're all fixable, and just set that expectation. I think that's the way to do it. So that's it for older houses. I know we have some questions here on the chat. So.
Hey, Don,
yeah.
Jennifer and I will read them out to you.
Perfect.
All right, so there's the first one. If you install a GFCI on each circuit of a knob and tube system, would that be deemed an electrically safe system by the ESA? I'm not sure if you can address that one.
ESA may say it's okay, but your insurance company won't.
Fair enough.
because technically you've taken care of it. I would be surprised if ESA allowed you to just get away with that rather than upgrading where you needed to. But, you know, for insurance, definitely not.
All right, Jennifer?
Does the city replace the galvanized pipes from the street to the house?
From the road to the house? No, that's up to you. Where your main water shutoff, sometimes you'll see it in the driveway, it'll be a cap about 3 inches in diameter with a nut in the middle of it. That's your main water shutoff. That's the city shutoff. You have your main in your house, you have the city. Generally from when you go straight down there, where that pipe connects into that valve to the house is yours.
Yes, I can attest to that. It happened to me as well. Go ahead, Jennifer.
Ooh. Insurance companies do not inspect homes before agreeing to insure, and that I know is a little bit incorrect because some insurance companies will actually send somebody occasionally to inspect, at least pre-COVID. A lot of times they will take the buyer's word and assume anything the buyer does not know. What happens if damage happens in the future as a report of unreported galvanized pipes or aluminum wires?
Probably a question for an insurance agent.
Yeah.
Yeah, I would say an insurance agent and a lawyer at that point.
Yeah.
Yeah, I mean, yeah, that's, I'm looking through that. Yeah, I mean, I mean, if they know about it, I'm sure there's some recourse, but is the money worth spending? That would be the question. Aluminum wire, I mean, if they don't report it, I mean, you're going to pay $1,000 to have all the outlets pigtailed. And let's say again, aluminum wiring is not an issue. It's the connections at the plugs and switches that are the issue. And if those are checked by an electrician during the ESA or prior to an ESA, that's exactly what the insurance company will require. If it passes the ESA, your insurance is fine. Unreported galvanized, if it's not visible, they really can't say you didn't disclose it, but there is a possibility, yeah, for sure. And that's why doing home inspections, using somebody who knows what they're looking for is very important.
If an oil tank is not in use any longer, is it still an issue other than the cost to have it removed?
If it is empty, probably not a big deal, but do you want something that's just space in your house that shouldn't be used? They should be removed because there's always a possibility of weeping and leaking and smells. They will deteriorate. Cost of removal, I've somewhere around $500 to $800, I believe, to take out a steel tank if there's no oil in it. It could be a little more if they have to pump it out. And
it has to be removed by somebody who's certified with TSSA, correct?
Yeah, they have to have a TSSA certification.
Right.
Perfect. Pre-drywall wallboard, circa 1949. Would that possibly contain asbestos?
The wallboard itself, probably not, but the plaster that's on top of it could, because it's a different product. So the wallboard is actually the same as the drywall we use today. So it's gypsum, which was mined locally. There's actually Caledonia has a big gypsum mine, and that's where a lot of the drywall came from. Gyprock is a brand name, which was made by Georgia Pacific, and it was actually, a lot of it came from Ontario. So it's a different type of product, comes from a different type of mine where there's not, asbestos is not a known issue in that.
And is there a definite year that they actually stopped putting asbestos into floor tiles and glue as well?
Most of it's the 9x9 tiles, and generally after 1970 you don't see a lot of it. Definitely after 1980 you don't see much of it. Excuse me, sorry.
Okay.
Are the companies using anything as a replacement to asbestos as a fire retardant in their products, and is there the potential that these products at some point could prove harmful?
I would, yeah, probably. If I'm understanding correctly, sorry, repeat that, Jennifer. You're in and out. I apologize.
Oh, sorry. Are companies using something other than a replacement as a retardant, as a fire retardant? Wow.
Oh yeah. So I think that responds back to the heating of the wood up to 90 degrees C and whatnot. We don't need to anymore because our ductwork doesn't get that hot. But there are replacements for that. We see rock Roxo, sound and fire insulation. They'll use some of that stuff around chimneys and whatnot now rather than asbestos and vermiculite. Glass, it's usually fiberglass and glass and minerals that are used rather than the asbestos.
Okay.
I think that's it for now.
Yes. I will
Other
answer
than
that. Can I answer that one question there?
the one about the wall board.
I can answer that one. Pre-drywall, would that contain asbestos? Probably not. Floor tiles too, from Jeanette. Yeah, most of the floor tiles don't have asbestos anymore after 1970, 1980.
Albert Ralph was the one talking or asking about the pre-drywall board. The one he's talking about seems to have layers of paper laminated into 4x8 sheets.
Oh, that's a wall board. Most of that is made out of paper.
Okay.
So there shouldn't be a lot of asbestos in that product. But it is anything from that era, you know, if it's questionable, the test is cheap. It's like $60 for a sample. If you do it yourself, I mean, it's worth doing. More than likely though, most of the I know what he's talking about, the stratified paper, it looks like probably not.
All right, good to know. And unless you have tips on maintaining old hardwood floors, I think that's it.
Use them, enjoy them, put a coat of Varathane on them, and enjoy it.
All right, thank you so much for your time. This has been very informative. We really appreciate it. Thanks, Don, and we'll see you again. We've got you still with a lineup to come for Mindset Mondays. So on that note, we will say goodbye to everyone and have a great
thank you to everybody. And if you have any questions, you are more than welcome to reach out to us.
Appreciate that. Thank you.
Have a good week and sell something.
Bye now.
Bye now.